Okay, let me talk about another topic, which is mean value. So what do you understand by mean value? So as we know that alternating current, magnitude of alternating current is changing continuously. So if I say what is the value of alternating current, it is 1 2 3 4, it's changing continuously. You can say any one value, but you cannot say any one value. So you have to know the one value for alternating current. Okay, if someone asks what is the value of alternating current, then you have to say one value. For that, we have to find the mean of this varying current. Okay, so this is the graph with which the alternate current is shown. Here you can see this and this has to be equal. Okay, it is not shown equal over here, but it has to be equal. That means this maximum peak and this peak has to be same. This time axis and this time axis has to be same. If this is 5, this has to be 5. If this is 0.5, this has to be 0.52. Okay, so if you find the mean, what do we do while finding mean? This is plus 5, this is minus 5. So if I find the mean, we have to sum it up. So plus minus cancel each other and finally it becomes 0. So if I find the mean value of this alternating current over this whole time period, over this complete time period, then this is become equal and opposite. So obviously it has to give you 0. So we cannot find the mean value of the alternating current for one time period. So we have to, what we can do is that we can find the mean value of this current for half cycle. Okay, that is for t by 2. Okay, so that's what we will do. We will find the mean value of this alternating current over this half cycle. Okay, there are three ways by which we can find the one value of the alternating current. First way is finding the mean. Okay, or average value. So as you know the rule, the average value of alternating current is, well, we know the formula, sum of this current over one time over this time period. Okay, sum of this current over time dt for 0 to t by 2, that is integration of I dt, integration of current over time from 0 to t by 2 divided by total time. Total time is t by 2. Total time is t by 2. So we are finding summing of the current over this time period. Okay, over time dt, and we are dividing it with this time. Okay, total time is t by 2. So this is the way we find the uh, formula for alternate mean value. So that's what we will do. Now we will sum it up. Now we will solve this one. We know I equals to I0 sin omega t. This is the general formula for alternate current, where I0 is the peak value, omega is the angular frequency, and sin omega t is the sinusoidal variation of this current. So if you replace it by this value, I0 sin omega t, will integrate this, and we know 0 to t by 2. Again, t is time period, which is 2 pi by omega. Time period is 2 pi by omega. How? Because we know that f equals to, omega equals to 2 pi f, and here we can write 2 pi by t. F is 1 by t, therefore we can write t equals to 2 pi by omega. So in place of t by 2 we can write pi by omega. So pi by omega, in place of that we could write. Okay, so finally we integrate it and minus cos omega t, and we solve it. Okay, I'll be sharing the video, Baiju's video, where they have done the solution. So finally we get the mean value as 0.637 I0, that is 0.637 times of peak value of current. Okay, so this is the peak value of current, which is 5 for this case. If I multiply with 0.637, then we will get around this side. So this is the average value of the alternate current we will get. Okay, multiply the peak value by 0.637. So every time if you know the peak value, you can always find the mean value by multiplying with 0.637. Okay, so this is one way of finding the average value. There's another way, which is called the root mean square value of alternate current. So why do we do this root mean square? Is because as you know that from the process of finding mean value, we cannot find the alternate current over one time period. We can only find the alternate current for half time period, because both halves are equal and opposite, and becomes, once we sum it up, it becomes 0. But instead of that, we can find another way to find the mean value of alternating current, which is called root mean square value. In that case, what do? We square the current first. Okay, so both sides, if you square the current, then the negative side will also become positive, and then we can find the average value of the current over complete time period. Okay, so here the definition, we just square the current over time and we find the current over complete time period, therefore 0 to t divided by total time, which is 1 by t. Okay, instead of t by 2 and 0 to t by 2, we write t and we square the current so that the negative part will also become positive and it cannot cancel out, and this way we solve this and we finally get root mean square value equals to 0.0707 I0, which is little bigger than mean value. So this is the root mean square value of current, which is 0.0707 times of peak value, that is 70.7% of the peak value. Okay. Similarly, voltage can be found in the same way, b0 by 2. We can directly write it as this. Okay, the same way like current. So this alternating root mean square value of current is very important because we use this value of current, root mean square value of current, whenever in case of AC. Okay, if any one value of current is given, that is root mean square value of current. Okay, usually at home we use AC, all the home appliances are used by AC. So AC, we say 230 volt. 230 volt is not the DC voltage, but it is the root mean square value of the AC voltage. Okay, root mean square value. So we don't use the mean voltage also, we just use the root mean square voltage. Okay, if any bulb is connected to any AC source, let's say, and the source value is given, let's say 250 volt, then that voltage is the root mean square voltage of AC. Okay.